Alright, so we looked at the complex fractions, the basic ones, where we're basically just doing keep, change, flip. Now we're going to realize that fraction bars are actually another form of grouping symbol, like a parenthesis. So if you encounter an order of operation problem that involves a fraction bar, they're really just like big division problems with parentheses, right? So if you see something like this, 11 minus 3, the whole thing over negative 3 plus 5, you really are viewing that fraction bar as a big grouping symbol. So what it's really doing is it's really keeping this 11 minus 3 separate from this negative 3 plus 5 until the very last step. So it really is the same as writing 11 minus 3 in parentheses divided by negative 3 plus 5 in parentheses. So that means when you have some kind of complicated fraction in an order of operations problem, you just basically treat the numerator and denominator like they're in parentheses and do them first. And then at the very end, then you simplify the fraction, right? So if you did 11 minus 3 over negative 3 plus 5, you do the numerator first, you get 8, then you do the denominator, you'd get 2, and then you do the division at the end. 8 over 2 is just 4. So here we see some more complicated examples of complex fractions that aren't just keep, change, flip problems, right? These are more like order of operation problems where you have to do the numerator and denominator separately and then do the division at the end. But it's no different than ones we just did, right? So you're just, in the first one here, you're adding 3 and 5, subtracting 18 and 2, and then dividing at the end. So you would just do 3 plus 5, get 8, 18 minus 2 gets 16, and then reduce this fraction. So now 8 will go into both 8 and 16. So 8 sixteenths is really 1 half, right? And now this middle one is a little bit more complicated because each one is kind of like its own order of operations problem. So in the numerator here, you have 4 minus 4 times 6. So if you remember the process, right, we had multiplication before subtraction. So here we would do 4 minus 24. And in the denominator, we have exponent and adding. So we're going to do the exponent first. So we do 3 cubed, but 3 cubed is not 9, right? It's 3 times 3 times 3, which is 27, plus 3. And now we just do the subtraction in the numerator, the addition in the denominator. 4 minus 24 is negative 20. 27 plus 3 is 30. And then now negative 20 over 30, 10 will go into both of those, right? So we divide both by 10, and we would get negative 2 over 3. And then in this last one now, we have a couple different operations in the numerator, right? We have multiplication, addition, and another multiplication. So this is one of those deals where the addition is going to get done last, so we can do the two multiplications together. So 7 times negative 1 is negative 7. Leave that plus sign. And then 9 times negative 3 is negative 27. So negative 7 plus negative 27. And then in the denominator, we have multiplication and subtraction. So we do the multiplication first, get negative 15 minus 2. And now again, the numerator and denominator are just addition and subtraction problems. So negative 7 plus negative 27, we're adding two negatives, so we get a bigger negative, negative 34. And then negative 15 minus 2, and remember when we did this with integer addition and subtraction, this can be looked at like plus a negative. So it's really negative 15 plus a negative 2, two negatives being added, they give you a bigger negative. And now we have a negative divided by a negative, which remember was going to become a positive. And also 34 and 17, 17 go into both of those. Two over one, or just two. Because remember, 2 over 1 is really 2. So for me, if you wrote 2 over 1 as an answer, I would take it. But when you're doing like a WebAssign homework problem, writing 2 over 1 will get marked wrong. They would want you to write it as 2. So before we do these last few, it's just good to remind ourselves of what the order of operation procedure was, right? It was basically a four-step process, beginning with operations that were inside parentheses and other grouping symbols. And as we see now, a fraction bar, right, that creates a complex fraction can actually be thought of as a grouping symbol. So when we have a complex fraction like that, what we want to do is we want to do the numerator and denominator separately first, and then at the very end do the division. And then we would move on to exponents after that. That's the second level. Then we would move on to multiplication and division, the third level, which it gets done from left to right. Remember, that was important, right? You don't just do it in any random order. It's got to be done from left to right. And then the final step was addition and subtraction. And again, that gets done from left to right. So that procedure doesn't change just because we're now dealing with fractions in addition to integers. All right, so we just have 3 more examples. And again, like I say, you really have to do the lab problems from this section, because the ones in the textbook are all complex fraction problems. There's no just traditional order of operation problems that aren't inside complex fractions. But we'll look at these ones from the book first, right? So we have 1 plus 4 squared all over 1/4 squared. So again, that big fraction bar there, this is a grouping symbol. So it's going to keep the numerator and denominator separately. So we're going to do the numerator first. So we have exponent and addition. So we do the exponent first. So it's 1 plus 16. And in the denominator, all we have is an exponent, right? So we just do 1/4 squared. So 1/4 times 1/4 is going to be 1/16. So we have 1 plus 16 over 1/16. So now the numerator still needs to be simplified. So it's 17 over 1/16. But now this is kind of like what we had done at the very beginning with our easier complex fractions, right? This is just like a division problem. So it's 17 divided by 1/16, which is really 17 times 16 over 1. And 17 times 16 actually is a big number. It's actually 170 plus 102. Is it I'm sorry, 272? I hope that's correct, right? 170 plus 102, 272. Yeah, I think that's correct. So that's going to be 272. And then this middle one now, it's just single operations in numerator and denominator. So you do the 2/3 minus a half first, get a common denominator of 6. So it's 4/6 minus 3/6, which is 1/6. And then the denominator, same thing, get a common denominator of 12. So that's 3/12 plus 4/12, which is 7/12. And now again, it's just like a keep change flip. So this becomes 1/6 times 7/12 flipped becomes 12/7. And then we could do our brute force. 1 times 12 is 12. 6 times 7 is 42. And then simplify this, right? What will go into both of those? Well, I know 2 does. 3 does also. So that means that 6 will go into both of these. Because since 2 and 3 both go into them, 6 will go into them. So 12 divided by 6 is 2. And 42 divided by 6 is 7. So that's just 2/7. Okay, so let's highlight these so we can see what we had. That was 272. This one's 2/7. And then this last one now, same thing, but actually this is a good distinction here, because in the numerator, right, you have a parenthesis and then you're squaring that parenthesis. So you do the parenthesis first, then you square. Whereas in the denominator, you do each square and then add, right? So they're not the same. The numerator and denominator are different. So in the numerator, I would add, get 8, and then square that. In the denominator, I would square each of these, right? I would have 36 plus 4. And now in the numerator, I have 8 squared, which is 64. In the denominator, I have 36 plus 4, which is 40. And now I would have to simplify it, right? So what will go into both 64 and 40? 8 does, right? 8 goes into 64 8 times. So this is 8 over, and 8 goes into 40 5 times. So that one would just be 8/5. So there you have it, right? But again, you want more practice with these order of operations with fraction problems, so you'll want to look at the lab and the homework problems also.